So let's do WebAssign electric fields and potential number 7, which consists of a charge Q and 2Q. There's 2Q. And the separation is, the way they show it is, these distances D, D, and D. So 3D basically across the whole thing. So here, x is equal to 0. And at some point along here, you want to find out where the E field is 0. Well, as you can imagine, as you get close to this, or close to this, the E field is not 0. E field is an inverse square law. E is equal to k q over d squared in general. So, and this is a bigger q, so it makes sense that it's not going to be at the halfway point. You know, being a vector, this electric field from this one is pointed to the left, and the electric field from Q is pointed to the right. But since this is a bigger charge, the electric field is going to be dominated overall by this one. So somewhere closer to this one, the 1Q, is going to be where the electric field is 0. Let me, because this is cluttery right now, let me put some point P here. P is the place where the electric field is 0 on a line across here. Now, I'm going to call that distance x, all right? And therefore, the distance from the 2Q is 3D, that's the entire distance, minus x will give us the distance from P to the 2Q. All right, so that's the situation. Now let me draw P again, because P is the point where the E field is 0. And that means that the E field from the 1Q, I'll say E from Q this way, right? Because this Q has an E field, it's a positive charge, so it's pointing to the right. The E field from the 2Q is in the other direction, E of 2Q. And basically those have to be equal. I didn't draw on the same length, but they will be, where the electric field is 0. So we just simply need to do E of Q is equal to E of 2Q. And now let's rewrite that. E of Q is k 1Q over x squared. That's our distance. And that's equal to k 2Q over the distance between 2Q and P, 3D minus x quantity squared. There's our equation to solve. And that's really ends up being easier than you think. Look at this cancellation. K goes away, Q goes away. So now we have 1 over x squared is equal to 2 over 3D minus x squared. Now it looks like that might be a quadratic equation because look at that. We got x in 2 places and it's squared. However, this problem becomes very easy when you realize it's begging to be rooted. Square root the whole thing. That gives us 1 over x is equal to the square root of 2 over 3D minus x. Isn't that nice? I'll answer that question. Yes, it is. And so now we can just cross multiply, and we get 3D minus x is equal to square root of 2x. So now what I'm going to do is bring this x over. So we have 3D is equal to x plus square root of 2x. And of course that combines as x times 1 plus square root of 2. And so now we can solve for x. X is equal to 3D over 1 plus square root of 2. And when you plug that into your calculator, you should get something like 1.24D. And that is the answer to the problem. I hope you enjoyed it.